Tonight we're going to talk about taking quotients and raising those quotients to a power. We're going to complete the following table. I'm going to complete the second row with you and then ask that you complete rows 1 and 3 on your own. So let's take a look at the second row. If we have negative 2 over x to the third raised, all of that raised to the third power, well that means negative 2 over x to the third times negative 2 over x to the third times negative 2 over x to the third. You just take whatever's in the parentheses. If that's raised to the third power, it's multiplied by itself 3 times. Then we're just dealing with these fractions. We're going to multiply straight across the top, straight across the bottom. We're going to get negative 2 times negative 2 times negative 2 over x to the third times x to the third times x to the third. And then we're just going to rewrite these using single exponents. So negative 2 times negative 2 times negative 2, well that means negative 2 to the third power. X to the third times x to the third times x to the third, well we have 3 factors of x here. 3 more factors of x, 3 more factors of x. How many factors of x do we have? We actually now have 9. 3, 6, 9. So in our center row, written with single exponents, it becomes negative 2 to the third over x to the ninth. What I need you to do is pause the video, try rows 1 and 3 on your own, and then come on back. All right, hopefully you paused the video. Let's take a look at row 1. 2 sevenths to the second power just means 2 sevenths times 2 sevenths. Multiplying straight across the top, 2 times 2, we can write that as 2 squared. Straight across the bottom, 7 times 7, we can write that as 7 squared. Finally, in our last row there, 2c over d squared all to the 4th power means taking 2c over d squared and multiplying it by itself 4 times. So we go straight across the numerator. How many factors of 2 do we have? We have 1, 2, 3, 4 factors of 2. So that's 2 to the 4th. How many factors of c? 1, 2, 3, 4 factors of c. So that's c to the 4th all over. How many factors of d do we have? Well, we have 2, 4, 6, 8 factors of d. So we write that as d to the 8th. And what we want to see is there a more efficient way to go about this. I think for now I will take a look at that third row and see if we can come up with a strategy for going from a quotient raised to a power to rewriting with single exponents on each part of our quotient. So what I first want to look at here inside the set of parentheses, if it's just 2, that means 2 to the first power. Sorry about that. If it's 2, that just means 2 to the first power. C is c to the first power, and then obviously on the bottom we have d to the second power. So I want to look at my exponents. I'll start down here in my denominator. D to the second raised to the 4th. What can we do with that 2 and that 4 to get to 8? What does it look like we're doing with the exponent within the parentheses and the exponent on the outside? This feels very familiar to what we did last night. Well, let's see. 2 times 4 is 8. So that could be d to the 2 times 4. Let's try it here. The exponent here is a 1. The exponent on the outside of the set of parentheses is a 4. So it's 2 to the first raised to the 4th power. What do I do with that 1 and that 4 to come up with a 4? Well, that would be 2 to the 1 times 4. And finally with my c, if I have c to the first raised to the 4th power, what can I do with that 1 and that 4? 1 times 4. So that's c to the 1 times 4. So it appears as though I'm actually using the exact same rule that I used last night. Except last night we were talking about products and now we're talking about quotients. You take the exponent on the outside of the parentheses, that power, and you apply it to each part of the quotient within. So you just multiply the exponent on the outside by each exponent within in order to get your simplified form. Let's just see if that works for the first one. This is 2 to the first, 7 to the first. So that means it would be 2 to the 1 times 2. Well, sure enough, 1 times 2 is 2. Let's try it with that 7. Exponent on the 7 is a 1. 1 times 2 on the outside. Sure enough, it totally works. And then I can go ahead in my second set of parentheses, negative 2 to the third power, and then 3 times 3 gets me to 9. So it's the same exact rule as last night. If we want to raise a quotient to a power, so if we're raising a quotient to a power, you're going to multiply exponent on the outside of the parentheses by each exponent within. And you'll keep in mind you'll be keeping all of your bases. So let's go ahead and take a look at that. Power of a quotient law of exponents. It says x over y all raised to the nth power means x to the nth over y to the nth. So 2/3 to the 4th means 2 to the 4th over 3 to the 4th. 2 to the 4th is 16, 3 to the 4th is 81. And the little guy says, so when I take a power of a quotient, I apply the exponent to all parts of the quotient. So you apply the exponent on the outside of parentheses to each part of the quotient within. Let's have you try a few on your own. I'd like you to rewrite each expression using single exponents. You're going to take a minute, pause the video, try it out, come on back. Okay, hopefully you paused the video. So for that first one, you may have chosen to write out your factors, which I'm fine with. And if you choose to write out your factors, x over 3y squared to the second power means x over 3y squared times x over 3y squared. If I multiply straight across the top, x to the first times x to the first becomes x to the second over 3 to the first times 3 to the first becomes 3 to the second. 2 factors of y here, 2 more factors of y. That means we have 4 factors of y, y to the 4th. That's just applying our multiplicative law. When we're multiplying exponents, what do? We're going to keep the base, add the exponents. So you could have done it that way, or you could have used our new strategy from tonight. And you could have just done x to the 1 times 2 over 3 to the 1 times 2, y to the 2 times 2. And that would get us x to the second over 3 to the second, y to the 4th. If you need to write out your string of factors, that's fine with me. So hopefully you tried the second one again. You could choose to multiply x to the third over 2y to the 4th by itself 3 times, and then simplify from there. In the numerator, straight across the top, 3 factors of x, 3 more factors of x, 3 more factors of x. We now have 9 factors of x. 2 to the first times 2 to the first times 2 to the first, that's 2 to the third. 4 factors of y, 4 more factors of y, 4 more factors of y, that's y to the 12th. 4 plus 4 is 8, plus 4 more is 12. So that would be a fine way to go about it, or we can use our raising a quotient to a power. We have x to the third times 3, because that's the exponent on the outside of the parentheses, 2 to the first times the 3, the exponent on the outside, and then y to the 4th times that 3, the exponent on the outside. That becomes x to the 3 times 3 is 9. 2 to the 1 times 3 is 3. Y to the 4 times 3 is 12. And you're going to notice whether or not you just choose to write out your base, however many times the exponent on the outside tells you, and then multiply straight across the top, straight across the bottom, you're going to always obtain the same answer as if you apply our quotient to a power rule, where you multiply the exponent on the outside of parentheses by each exponent within, keeping our bases the same. Now the power of a quotient rule also works in reverse. We're going to rewrite each of the following as a power of a quotient. It might sound complicated, but it's really not that hard. If you have 9 squared over 10 squared, that's the same as saying 9 over 10 to the second power. Because 9 to the first, 1 times 2 is 2, 10 to the first, 1 times 2 is 2. So 9 squared over 10 squared is 9/10 to the second power. Now I'd like you to pause the video, try the first one. It shouldn't take you more than 30 seconds, and then come on back. All right, hopefully you tried that first one. That just means 5/6 to the third power. Sometimes it's helpful for us to be able to go both ways with these rules. Finally, for your reflection question tonight, I'd like you, in your own words, to describe our fifth law of exponents we talked about, raising a quotient to a power. I'd like you to use words and an example if you're able to. So do a nice write-up on that. Be ready to come on to class. We'll pull a card. Somebody will come up and share. Try to have a good night. Thanks. Bye.